Okay, so hi guys, welcome back to Leetcode, and so today we are going to solve valid anagram. So let me tell you what is anagram. Anagram means a word or a phrase formed by rearranging the letters of a different word or a phrase, typically using the original letters exactly once. So it's like using all the original letters exactly once. The frequency are same, everything is same, the characters are same. Just we are arranging it. So let's suppose it's like let me change the background. Yeah. So let's suppose we have uh, you know uh, let's suppose car. The anagram can be ARC. A is one time, A is one time, C is one time, C is one time, R is one time, R is one time. So this is an anagram. Well, next TAC and CAT. T is one time, T is one time, A is one time, A is one time, C is one time, C is one time. Well, we have to make sure the input strings. There will be two input strings. So here the two input strings passed as parameters or arguments. So these two strings must be lowercase as said here. So these are the two given strings. We have to return true if these are anagrams of S. I mean, these two are anagrams, or else we have to return false. Well, here it's written like S and T all contains lowercase, so we don't have to change it to uppercase or something. So it's not uppercase; it will be lowercase. So it's just the same. Sorry. So let's move on. I have to change the format of the background again. Yeah. Now, let me ask you a question. Okay, let's discuss the edge cases. Let's suppose I have a okay. Okay, let's take an example of the last examples I took, that is TAC. What's the anagram of it? It can be anything. It can be ACT. It can be CAT. All these are anagrams. So it is suppose it is S. This is T, and this is U. So these can be anagrams of each other. Okay, so let's not take S right now. Okay, so we have to find, or let's not take U right now. We have to find the anagram between these two actually. What if I remove a single character? Let's suppose I have written C. I have not written, I mean I have removed C. So S is T A, and what is T? T is ACT. I have just removed C from here. Can you say, are these the two same? I mean, these two are anagram. Can you say that? No, because the frequency is not same. The C's frequency is zero. C is occurring zero times. That means if the length of S and T is not equal, then we can directly return false. That is our edge case. So we can just directly start with the edge case. If S dot length is not equals T dot length, we can just simply return false, right? Or I guess we have to return true, because the frequency of these are same. And okay, so we have to return false, my bad. Yeah. Okay, yeah. And if S dot length is is equals to 0, and T dot length is equals to 0, return true. Why we are doing this? Let's suppose the user passes a null string. This is S and this is T. Now the question arises that if this is a null string, there is nothing in between. There is nothing in between. So there is no string and there is no string. So the frequency is same. The frequency is 0, and here also the frequency is 0. Can we say we don't have to compare further? We can just simply return true because these two are same. Yeah, the frequency is same, 0. So we have to return true. Now We have two approaches to solve this. The first approach, that you should tell your interviewer is, we can sort the strings. By sorting, I meant, like, let's suppose it's CAT. According to the index in ASCII, A comes first, and alphabetical order. If you sort, A comes first, C comes at the second position, and T comes at the end. So this is the sorted. And what about TSE? TSE, same. A comes first, then C, then T. And with that said, we can just simply do one thing. We can check the edge cases first. In the sorting method, we have to sort and compare. So we have to create an character array, and in that character array we will store string dot to character array, and C1 we can just do C1 and C2, and C2 will be storing t dot to character array. And once done, we can just sort arrays dot sort C1, and same for C2, and we can just create a new string, or either we can just simply compare these two. Like, let's suppose we can run a loop from I is equals to 0, I is less than s dot length, and I plus plus. And if C1 at I, the character at C1 index, I mean the ith index of C1, if it is not equals to C2 of index I, then we can return false, because the character is not matching, the frequency is not same, we can return false. So this is like char C1 is equals to s dot to character array. Now char C2 is equals to t dot to character array. We can do one thing, arrays dot sort C1, arrays dot sort C2. Now once done, we can simply run a loop. I is equals to 0, I is less than s dot length. Why I'm running s dot length? You can say like, it's just because the length of s and t is same. How did I figure it? Because if it's not same, it will directly return false, because the frequency is not same. And if the frequency is not same, it can never be an anagram. Now if c1 at I is not is equals to c2 at I, that means the character at that at both the indexes are not same, we can return false. And at the end, if everything goes fine, we can return true. Let's run this. Okay, I guess, okay, there's a small issue. Let's run it again and hope for the best. Hope we don't find any further issues. Yeah, it works great. Let's run this. Cool. 8ms 46.3. So let's discuss about the time complexity. So the time complexity is O of n log n at max. So it's just like O of, let me show you, O of n log n plus O of n, and the maximum of these two is O of n log n. So this is just because we are sorting, and this is for three reasons. We are storing the strings in character arrays two times, plus we are using sort method that uses extra space to sort the elements. So the total time complexity is O of n log n, and the space complexity is O of n. This is the time complexity, O of n log n. Now we can discuss the next solution, that next approach. I would say we can create a array. I would say hash array. So this we have it's been said that we will be getting lowercase characters. Now we can create an length of alphabets in English, that is 26. So can we say, if that particular index, suppose I have a right here, a is at 0, b is at 1, c is at 2, d is at 3, and e is at 4. Can I say, if I subtract any character with a, I will get the index of that character. So suppose I have an array of 26, so this is the index of that array, this is the index, and so on and so forth. It will continue till 25th 25th index, because it's starting from 0, right? This is a range, dot 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 5 6 7 dot 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 25. Got it? E F G, and this will be Z, that is Z. Now if, can I say, if I subtract, let's suppose C minus A, what I'm getting? 2, right? 2 minus 0, that is 2. Can I increment that particular index, that particular character minus A, that will the index of that character? For C, what will be my index? 2, because C minus A, 2 minus 0 is equals to 2. So this is my uh, index. I will increment the value at this index of this hash array. So this will be 1. Initially it's all 0, right? It's 1. Now C C A T. Now at C we have C minus A, that is 2, increased. Again C, 2 minus 0, C minus A is equals to 2. Again we will increase this to 2. A minus A is 0. 0th index increased. T minus whatever it is, we will just increase. Let's suppose we have race car. R increased. R, that is index in that hash array. So what we are doing is, we are just incrementing the counter. The array is initialized with 0 by default in Java, you know, right? So what we are doing is, we are just finding that index of that character corresponding to that character, and we are incrementing every time we found that character. So ultimately my approach is, I will check the edge cases first. I will create a new hash array of 26. Now I will loop from 0 to n minus 1, or that is s dot length. So once done, I will increase the counter at index, I mean char at I minus a plus plus, and I will decrease the counter of char at I minus. Can you say why I'm increasing and decreasing first? This is for string s and this is for string t. So if for the string s, I will increase the counter of that particular character in the index, and for the string t, I will decrement the counter of that particular character corresponding to that. And once done, I will loop again. I will loop again, loop from 0 to s dot length. And if I found, if s dot caret at I, it's not caret, I mean it's hash array at I is not 0, then we can return false. Got it? Let me explain you with an example. Let me give a dry run example. Suppose we have C A T and we have A C T. This is my S, this is my T. And, or let's take a small example that will make more sense. uh yeah, okay. BAD, okay, BAD and DAB is not looking great. BAD and DAB, bad and dab. This is S, this is T. For this, let's suppose I have an array 0 0 0 0 0 dot 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 till 25th index. This is not 25, this is also 0 till 25 index. So this is my 0 index, 1 index, 2 index, 3 index, 4 index, 5 dot 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 25. Got it? Now, for the first time, my I is at 0. This is my I is starting from 0. As said earlier, I is starting from 0 to n minus 1, that is s dot length or t dot length, because both are, the length is same. Now, what is caret at s? B. B is 2. So b minus a, 2 minus, sorry, b is 1. 1 minus 0, 1. I will increase this. Now, pointer is all, pointer is currently at 0. And what is the character at 0 for t? It is d. I will increase the counter for d. That is 3. 3 minus 0, 0. Okay. Now, let's suppose once done, once decrementing, I mean, okay, there's an issue. What I did wrong is, we have to increase for s and decrease for t. So what I have to do here, I think you have guessed it. We have increased b for s and we have to decrease t for t. We have to decrease it to -1. Next, I is at 1. What is that first index of s? A. Increased. What is that first index of t? A. Decreased. Again 0. It's not 1, it's 0 because we have decreased. T minus minus s plus plus. Now I is at 2. What is that index at 2? Can you tell? It's d. It was 1 minus 1, so we have to increase it. For s it will be 0. What is at the third index of d t string? That is b. We have to decrease it. 0. Can you see? It's all 0 now. 0, 0, 0, 0, 0, dot 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 0. We have not touched it. The loop ends over here because the string size is small. Can we see? Okay, so that means anything happens, the frequency, we are just adding the frequency. Add frequency of character for s and subtract frequency of character for t. So if it is AAA for s, it must be AAA for t. So if all the frequencies are being cancelled out. Got it? So this is the approach. We have to make a hash array of size. You guessed it right, 26. Now we have to loop int I is equal 0, I is less than s dot length, I plus plus. Now we have to increase the hash array. Hash of s dot char I minus a plus plus. Hash st dot char at I. What we have to do? We have to increase it. So I mean decrease it. We have to decrease it. Yeah. Once done, we have our array ready. Now we have to check if the frequency are same or not. How we will check? Check it is 0 or not. If it is not 0, then the frequency is not same. Loop again. uh, okay, we can just simply use for each loop. Let's check. It works. Let's submit. Cool. 7 ms, a little better. Once you run it again, it will show something different on time. So that doesn't matter actually. Look, 5 ms. It's I didn't change the code. It's too different. So let's discuss about the time complexity for this one. So the time complexity for this one is okay. So for the second approach, time complexity is, you can see we are looping one time every time. I mean, yeah, one time only. So for loop 0 to s dot length, because the length are same. So either it will be either of these two, that is same, and we are looping again. So that is for the second. This is for the first approach. This is for the second approach. O of 2n. This is TC, time complexity, or O of n simply, and the space complexity is O of n. Why O of n? Okay, sorry, it's not O of n, it's O of 26. By O of 26, because we are creating an array of hash that is of size 26, and as it is a constant, we are not changing, or it's not defined by user, and it is a constant value. Can we say it is nothing but O of 1 because it's constant? Neglecting the fact it's constant, we can say it's O of 26, but technically it's O of 1 because it's constant. Yeah, so the time complexity is O of n, the space complexity of O of 1. Is it decreased? Log n, I mean n log n and n. So this is the better one, better approach. This is O of n and this is O of 1. We have done it in constant time and in one, one single loop is fine. So once done, like yeah, this is the answer, and I don't think I've missed anything. These are the edge cases you can check. This is an extra thing you can do in the interview that might impress your interviewer. And yeah, I think that's it for now. And yeah, see you until in the next video, and till then, bye bye, take care, peace.